we're talking about k-mean, and we are going to talk about other clusters as well. They don't exactly visualize the data set and based on that saying, okay, the cluster is here, cluster is there. The reason that we are actually seeing the cluster is because we are visualizing the data set. But these k-mean, dbScan, and other clustering method, they can actually visualize the data set and see the cluster with their eyes. But what they do, all of these are happening based on math and formula. So this being said, we talked about k-mean, how it can make mistakes and put two clusters together or separate the cluster in two clusters. There are ways that you can improve the result of these clustering. Silhouette de score is one of these ways. Basically what silhouette de score does, it just tells you how close your point is to its own cluster, and also how far away this point is from other clusters. Or the way that they explain it about silhouette de score, the cohesion and separation. So based on this, it will give you a score, and this score is between -1 and +1. The more closer you get to 1, that means that your clusters are more cohesive. That means that that point is closer to the center of your cluster. And then the more you're getting to -1 means that the more farther away your point is from your cluster. And in fact, it is so far that it's closer to another cluster. And if you are at 0, your data point is borderline. It's not close to the cluster that it is right now, and it's not close to other clusters either. So it's like whatever. Like the ones that you can look at the data set, visualize the data set, and you can easily say, oh, there's a cluster there, there's a cluster there, there's a cluster there. It will do great in those type of clusters because it can easily say, so you got -1, this point that you already assigned to this cluster is not actually belongs to this cluster, it belongs to the other cluster. Also, for silhouette to score, you can either define the score for each individual data points, or you can get it for the whole data set. If you're getting it for the whole data set, it's like the average of what each point did. So it will tell you how well your algorithm did overall. And if you do it for every single point, you're just figuring out if that single point is assigned to the correct cluster. And again, keep in mind, if you're getting a -1, it does not automatically mean that you assigned the wrong cluster. Since it is using Euclidean distance mainly, it will have trouble figuring out more complicated data sets.